Hello, everyone. Hi, and welcome to our session today, Tiny but Mighty, Unleashing the Power of Small Language Models. My name is Moria, and I'm a Regional Reactor PM at Microsoft. I will be moderating today's session and assisting the speaker with the chat. For those of you who are new to the Reactor, and this event is part of the Reactor program, the Reactors are community spaces for developers, startups, and students when you can connect and meet other professionals like you to learn about different technical topics. We offer events both in person and online, and soon you can see that we have actually 10 physical locations. So if you are lucky enough to stay next to one of their location, you can attend in-person events. Otherwise, we offer live stream events pretty much every day on different time zones. You can scan this QR code and check out our website to find out more about the upcoming events that we have next to your region or close to your time zone. Don't worry if you missed any of the QR codes. I will be sharing the links with you in the chat pretty soon. So here you can scan this QR code to register also for our newsletter. We have a monthly newsletter that we send, and you can choose the location where you are joining from, and you will receive monthly updates on the upcoming events you can attend. I also forgot to mention all the programming and the Reactor events are definitely free. You don't need to do anything to attend our events, even if it's virtual or in person, just sign up. A lot of our events are actually supported by Microsoft Learn modules. So if you haven't checked out this platform, really highly recommend you to visit Microsoft Learn. Microsoft Learn offers, I think, thousands of resources for you to learn on different technical areas. You can get access to certifications, to on-demand content, learning path modules, blogs, really everything that you need to get study and skill up. You can decide, you can choose your professional, your level, and the technical area that you're interested in, and you will have all the list of all the access available for you. If you scan this QR code, you will reach the Microsoft Learn platform. And if you scan this QR code, and again, I will share it soon, you will reach the AI Learning Hub, which actually gathers all the relevant resources that you can learn on around AI. And this is part of the Microsoft Learn program. Before we start, just a bit of housekeeping. This session is recorded. The recording will be available for you on the Reactor YouTube channel. I will be moderating the session, as I said, so feel free to ask any questions you have for the speakers or anything at all in the chat. I will be happy to help. Take a minute, please, to read the code of conduct for our Reactor events. We are seeking to provide a safe and welcoming environment in the chat, so please take a minute to go through the code of conduct. And without further ado, I'm going to hand it over to today's speaker. So we have Lee Stott, Principal Cloud Advocate at Microsoft, and Ryan Popat, Microsoft Student Ambassador. They're both going to deliver today's session. Enjoy, everyone. And Lee and Ryan, over to you.
Hi, everyone. Thanks for joining the session. So I'm Lee Stott. I'm a Principal Cloud Advocate at Microsoft. And I'm here to really talk to you today about small language models. If we could just share the slides, thank you. There we go. So there's a slide deck. So I'm Lee Stott, I'm a Principal Cloud Advocate at Microsoft, and I'm here with Rayan. Rayan is one of our amazing student ambassadors. So Rayan, do you want to quickly introduce yourself and tell us where you are and what you do?
Hi, everyone. My name is Rayan. Yes, as Lee introduced, I'm the Microsoft Student Ambassador. I'm currently studying at King's College London, majoring in computer science with AI, so a really exciting space. And I'm super excited to bring you guys to this session today on small language models. Often gets a little bit out of the spotlight by large language models, obviously a buzzword we've all heard about. But yeah, currently in Nairobi, Kenya, that's where I reside. And yeah, happy to be able to deliver this from the African continent, yeah.
Excellent, Rayan. So as Rayan said, we're going to really try and dispel a lot of the myths around what a small language model is, what a large language model is, and also really show you some great examples of how you can use small language models and what the key advantages are of using small language models. So we're going to be here for the next 45 minutes to an hour. Again, we want to show you some things that you can get hands-on with. So we do have lots of QR codes available within this slide deck. So again, if you want access to these demos, you want access to the content, please just scan the QR code and you'll go to the most appropriate GitHub repo for that resource. So let's get started. So key things are, we did a bit of intro about who we are. My team at Microsoft is focused on what we call AI core. So we're very much looking at the future of the AI platform. And again, looking specifically at like the cutting edge technologies like small language models. And again, I've been responsible for the work with the Phi team, so the Phi family models around the Phi cookbook. And we work really closely with both the product teams, our communities such as MVPs and Global AI and Microsoft Reactors, but more importantly with student ambassadors like Rehan. And what we want to do is work with our student ambassadors to give them a great opportunity of co-presenting with us. You know, we're the experts. And again, this really helps you as an audience understand that it doesn't really matter what level you are. We want to try and provide content, resources, and that onboarding from a level 100 beginner to a level 400 expert. So this session, we're going to go all the way through all those different levels and show you the types of resources and content that you can utilize. So let's talk a bit about what today's agenda is. First of all, we'll give you a higher level introduction to what small language models and large language models are. And we'll talk about the different tooling that's available to you as developers. So we're really looking at two primary things, which is Azure AI Foundry, which is our first code developer experience for building AI solutions. So that's using either what we call AI services, cognitive services, that some of you might know them as, or more generative AI services, things like Azure Search, models, etc. We're then going to talk about the most important thing when you come to actually building a solution with either a small language model or a large language model, and that is choosing the right model. And we're going to talk about some of the benefits and some of the constraints that you need to think about when choosing those models. We're then going to compare what a small language model is to a large language model. Some of you may have never heard of small language models or even large language models. So we want to give you some facts and grounding to which solution to use, why to use it, and what the characteristics are. And then we'll talk about how to actually start to deploy these models at the edge. And this is where small language models become tiny and mighty. You know, being able to put that model as close as possible to the compute is really key to the success of modern day AI intelligence. So if you think about cars and automobiles, you know, infotainment systems, visual warnings of traffic signals, they are all now using small language models. Again, think about that being like at the edge in an agri-tech environment. Agri-tech could be global across the world where there might be very low bandwidth internet like white space, or there may be no internet. So you want those language models to be able to operate without any connectivity. And then hopefully we'll have time for some questions and answers where we want you as the audience to put questions into the different streaming channels, and Maria will help facilitate a Q&A session at the end of this to hopefully help answer some of those questions that you may have around the content and the services that we discuss. So let's start with that high level overview of our AI tooling and services. From a Microsoft perspective, we're trying to really offer you the best in class AI services. So we start with things like AI services, which were previously called cognitive services. So if you use things like vision, text, and speech, they're part of our AI services bundle. We then have our traditional machine learning services, so where we call Azure Machine Learning. So that's things like PyTorch, TensorFlow, Keras. It also goes into things like Databricks, etc. So that's our traditional data science machine learning platforms, which is high compute, clustered compute. We then have our two key technologies. So as I said, we have Azure AI Foundry. This is a new name for a service which was previously called Azure AI Studio. And what we're trying to do with the Foundry portal is bring all these different things into a single portal where you can build the best AI solution. And then more recently, we've launched AI Toolkit for Visual Studio Code. So this is an extension for Visual Studio Code, which gives you a lot of the AI features and services around building small language models, large language models, and doing that evaluation, and also working with things like the Azure Model Catalog and the more recently launched GitHub Model Catalog. So we see Azure AI Toolkit being much more of that prototyping, MVP, experimentation on your local machine. And again, you're constrained by your machine that you have, whether you've got NPU, GPU, CPU resources, but you can carry out that experimentation at pretty much low cost or no cost if you're using GitHub. And then once you come to that deployment and productionization of the solution, move to AI Foundry. And most importantly, around all this, what we're doing is we're providing responsible AI. So this is really about those boundaries and security, governance and controls of building AI. We're in an era now where we can build it, but the question you should first ask yourselves is, should we be building this? And if we do build it, what are those compliance restrictions that we need to have as an organization, and ensure that transparency on that solution that we provide? So things like groundedness, relevance and coherence of the model. How are we guaranteeing that to our business decision makers? How are we protecting ourselves from jailbreaks, prompt injections or other attacks around our LLM? Because, you know, if we're putting an LLM out there, we want to protect it and govern it to make sure it's as safe and reliable and responsible as possible. So always consider responsible AI. Responsible AI is a foundation to everything that you do with AI. And again, it should be the first question you ask. So when you come to consider a model, there's various aspects that you should be thinking about. Number one, it's the quality of what you want your model to be. Is it rough and ready and you can utilize anything? Or do you have to think about a specialized or a fine-tuned model to actually utilize it? This then comes into that customizability. You can take a base model, so a model that's available on Hugging Face, Azure Model Catalog or GitHub Model Catalog, and utilize it. But you might want to fine tune that model to do a specific task. For example, you might be building a robotics manufacturing plant, which picks up big pens and places them in a cardboard box. Now, to do that, you might want to say, right, we're going to use a specific model, but we're going to fine tune our model to only understand different types of pens. Then you want to understand the features. So this is really like your scope of what your project is, what the features of the solution that you need to implement. And then most importantly, the price. So we look at the cost of actually implementing this. So cost within large language models is based on tokens, so the number of tokens utilized, but also the compute cost of doing this. So is this going to be a model as a platform, a model as a service, or are you going to have this hosted on your local compute machines running just like the actual inference? So again, you've got to think about the cost of how this is done. More importantly, you have to consider like how you're going to measure the performance of this. So the tasks that are going to be completed, if you're rolling this out into a production line that changes every week, what is that update cycle? What is your Gen AI ops life cycle? How are you going to do that continuous integration deployment of those new models? How are you going to retool your robots to have that new technology? And this really then leads into performance metrics. You know, what's your failure rates? What's the data requirements? Do you already have data? Do you need to create synthetic data? What's the computational efficiencies of this? Are you going to run it all in the cloud on GPUs? Or does this need to run on an Android phone of this model or this specification or of this version? Again, responsible AI is really key. The ethical constraints and considerations. What are the ethics around your solution? And again, what's the community support and documentation? You know, that's a key thing about learning this new technology. No one is an expert in this today because things are changing every day. Sora came out yesterday. So this is like an evolving thing where you might build a solution today and think, oh, should I change it to a newer model? And this really comes back into this evaluation of, just because a new model is out there, do you need to change it? What's the benefits going to be? What do you need to change to adapt to this new model? So there's some of the key considerations you need to make. So if we look at now like comparing of a model, so I'm going to pass this over to Rehan to talk about some of these different characteristics and advantages and disadvantages.
Fantastic. Well, thank you, Lee, so much for such a great introduction to what we're talking about, especially Microsoft's tools that they provide for allowing students like us to really access and develop on the most cutting edge AI technologies. It's really a fantastic effort. So now we're going to move on to comparing SLMs to LLMs. Now, really, the big definition is that anything with less than 10 billion parameters is considered a small language model. For reference, ChatGPT-4 has 175 billion parameters, but 5.3 Mini has just 3 billion parameters. So that's the key difference here. Small language models are less computationally intensive and often have a simpler architecture than large language models. Large language models require significant computational resources, and they are, really capable of understanding and generating complex and nuanced text because of their high understanding. But small language models really have a great number of advantages as well. Like we mentioned, they can operate on the edge, which creates a whole large use case of products that you can use small language models because they can operate directly on the end user device rather than having to run on a server or something and connect to it. Small language models have faster training and inference times, and they are often lower computational energy costs. However, large language models often have great advantages as well. They have superior performance, especially when it comes to diverse natural language processing tasks, and they're really better at understanding context and generating more coherent responses. What are some disadvantages of small language models? Well, as we mentioned, sometimes they have a limited performance on really complex tasks, and they're less able to understand really complex and nuanced text. But there's also disadvantages with large language models. They come with high computation costs, as we mentioned before, often longer training times as well, and they require super large data sets for training. So if we move on to the next slide, we can talk a lot about the quality and size that you find in different SLMs. We can see that the Phi 3.5 SLMs often have outperformed many large language models in terms of quality. They deliver really high performance while maintaining such a small size, and this is really impressive. Just to clarify, the benchmark on this graph is, we're evaluating the size in billions of parameters versus the model quality. And you can really see that the, Phi 3.5 MOE has a higher performance standard than some of the larger, parameter models, such as, Google's Gemma 2.27b, or even Mistral's open source models as well. So the key takeaway here is really efficiency. So why would you deploy massive models like Mistral or Gemma, that have 20 to 40 billion parameters when Phi delivers comparable or better results with far fewer parameters? Smaller models like Phi offers faster deployment, lower compute costs, and more energy efficient, all without compromising quality. This is especially crucial for real-world applications where resource optimization really matters. Overall, Phi is really setting a new standard by showing that you don't need to scale endlessly to achieve top-tier results. We can move on to the next slide. So now let's talk about customizing your model. Some people may say, large language models are, easy to customize. They want that maximum performance, but small language models are also really easy to customize. So let's talk about two main ways that you can customize your small language models. The first way is another big buzzword, retrieval augmented generation, RAG. For those of you that don't know about this, you can allow pre-trained models to have knowledge about your specific data. It allows the model to retrieve relevant information, which is really ideal for tasks requiring up-to-date or domain-specific knowledge. This can apply to, for me as a student, I can use RAG to access all of my documents and really perform better at studying because it knows about all the notes that I've taken. Or as a business, you can have all of your different contracts or tenders that you really want to work with, and you want to keep it private. You don't want to send all this data, out online. So you want to have an in-house model that knows all your data and is able to really perform and create great inference from the data that you have. Both methods, as well as fine-tuning, are great ways to meet unique requirements. Fine-tuning is allowing pre-trained LLMs to adapt to your new tasks or domains by adjusting its weights or parameters based on new data. That can really help to align the model style. It can help to reduce hallucinations and improve efficiency. So as I said, both models are great ways to tailor AI models to meet unique requirements and ensure that they provide really relevant and precise outputs. But you also have to be careful with this, as you can sometimes create a super overfitted model by over tuning the hyperparameters, and that can lead to poor output. So you really have to try and find a good balance.
Yeah, and you picked on a really interesting thing there about fine-tuning. I know one of the key questions lots of people have is like, how many data sets do I need to fine-tune a model? And again, if you're looking at a small model, our rule of thumb is about 100 data sets to train a small fine-tune model. For a large language model, up to 1,000 data sets. So again, you've got to think about the application. And again, if you want to bring this model to the edge, to your local device, you need a small language model. Training GPT-4o is going to cost tens of thousands of pounds, or it's going to cost a lot of money, and it's going to take a lot of time to do it as well. So it's not just a training time, which is based on tokens, it's the compute time that is taken and the compute requirements to train the model, where training a small language model, which ends up around 2 gig in size, a lot faster, a lot more cost efficient. So again, think about your use cases. So fine-tuning is very key. And again, lots of models are out there which have already been fine-tuned. So if you see a model that says like MOE, Master of Experts model, that's been fine-tuned. If you see a model that says Instruct, that's been fine-tuned to be an instructor model. So there's lots of fine-tuning and optimization already happening to models in the model catalogs.
Yeah, that's great advice. I mean, I personally didn't even know that when you add instruct to the end of the model, that means that you're talking about fine-tuned models that are specialized for chat applications, which I think is super important to have these different fine-tuned models for different applications. So yeah, let's move to the next slide. So we're going to talk a little bit about the access to the GitHub Model Playground. So the GitHub Model Playground is really fantastic for students like me. It's a great AI toolkit that's based off GitHub. It's free. It provides access to a set of AI models for anyone with a GitHub Model account. With a GitHub account, which makes it super easy for students like me to get familiar with AI models without having to create Azure resources or spend money or even download models from Hugging Face, which can take a lot of storage. So some key features of GitHub models is that, one great thing is that they have seamless integration with code spaces, which allows for great quick learning and engagement. For students like me who don't have access to like super compute or NVIDIA chip, hardware, it's great that we can use code spaces to sort of provide an on the web developer experience, which allows us to work with these GitHub models in a really fantastic way. Furthermore, the GitHub models has ease of local use. They're free and it's code that's already been written. So why would you start from zero when you can start from one? Furthermore, GitHub models makes it super easy to switch between different models. So if I wanted to experiment with, let's say, the Llama models versus the Mistral models versus the Phi models, it makes it super easy for us to switch. And we'll do a demo on that later on, which I'm super excited about, where we can show you really the difference and how easy it is to, sort of evaluate these different models, small language models against one another. And we do that using the Azure Inference API, which eliminates the need to change code between providers. So yeah, we're really excited to have that demo later on.
Yeah, and the Azure Inference API is a great example of how, as a developer, you can start to evaluate your models. And this is really key, that evaluation piece. You should be, when you choose a model, you should be looking at the benchmark. So each of the model catalogs has like a benchmarking feature where you can benchmark your model to say, how does my model perform? Or if I'm looking for a classification model, which model should I choose? But then it's that human evaluation piece of like, let's test this. Let's see what the output is. Is one more verbose than the other? Is one more concise than the other? That's a great example of how you can start to use manual evaluation.
Great. We can move to the next slide. There we go. So now let's talk about sort of the access that Azure gives you to the latest open source and foundational models. I mean, there's nothing like this in terms of the range that you're able to see. They have models from the Hugging Face family, from the Azure OpenAI family, the Microsoft family, from Cohere as well, Mistral, Meta, Stability AI, the NVIDIA family as well, Snowflake and Databricks. So really a huge amount of models that you can play with. And you may be overwhelmed, but really the Azure AI Studio makes it super easy for you to explore all these models and experiment with them in the Azure AI Studio Playground, where you can test and fine tune these different models to suit your needs. Azure AI Studio is super exciting because it also supports the full lifecycle measurement of deploying a model. So you can start with prototyping a model, identifying it based on what Lee said on the different benchmarks that it has on public data. Once you find a model that you really like, you can start to optimize it. How do you test prompts and iterate using manual evaluations and smaller data sets that are more relevant to what your business is trying to use? Then you can move to the third step, which is really operationalizing these models. How do you measure the quality and safety more broadly with automated evaluations? You can come out with a fantastic model, but you really want to make sure that it's robust, not only in its safety, but also in terms of, models, prompt injections. Is it able to answer the most important tasks that your business may need? And this is a great way for you to really access this entire full lifecycle measurement. Great. So we will move on to the next slide, which is it's a great demo on the Phi 3 Onyx Web GPU. So this is really going to show, if you can see my screen. Lee, can you see my screen? Is that showing?
No, so if we can just share your screen, right?
Okay,
there we go. We can see it now.
Okay, so here we go. So here we have, on the Chrome web space, it's a really great way for us to host, Phi 3.5 models on the web. So here we can see that, I can ask it a question: what's the difference between AI and ML? And hopefully it'll give us a great answer. Might take a second. There we go. artificial intelligence, AI, and machine learning are closely related fields, etc. But I really want you to pay attention to down here where it says the tokens per second. Now, these are small language models, but they provide a great output. Almost 10 tokens per second is fantastic. Just for you guys to know, the average reading speed is just 15 or 20 tokens per second. So, it's really quite fast in terms of how small it is. And it's what's great about it. And if I just show you guys on the Chrome Developer tab, if you go to Application, and I click on the cache storage. Hopefully that loads up. Here we go. You can see that we've got all these models loaded into the cache of the web page, which is really great. And if I can show you this over here, you can see that the model we're using, the 3.5 mini, it has got just over 2 GB worth of data stored on the cache of the web, which is great because this is small language models that are being deployed on the edge of applications, which means that you don't have to host them, but they will operate directly through the web, which I think is fantastic. This model is optimized using the Onyx framework and it's displayed using WebGPU. But it's really great because, here we're able to use these super robust, language models, but they're all deployed on the web, which is something that I found super surprising when I first learned about it. Great. And
this is a really exciting demo because I was just going to say, Ray, and this is a really exciting demo because the actual model has just been downloaded to the web browser alone. It's not anywhere else. It's literally just sat in the web browser cache. So as soon as Rayhan closes the browser, the model is gone. So this is really showing like how you can deploy small language models to pretty much any device. And this is the key goal behind this is it's using a thing called Onyx. And the Onyx model is that quantization and compacting of the model to be the most efficient and effective size. So this is like just where we're going with small language models and access to edge devices. So think about things like smart rings, mobile phones, watches. Small language models on those devices is now 100% available.
That's amazing. So you can really have language models on smartwatches, which is something I find super interesting. Okay, great. So we will move on to the second demo, which is all about hosting applications no longer on the web, but using Chainlit to how do we evaluate the different models that we want to use. So if you guys can see my screen, hopefully I can make that a little bit bigger.
Yep,
great. So what I really want to go through is some code right now, which may seem a little bit daunting, but it's quite easy once I explain it. So here we're using the GitHub inference model where we pass the API a bunch of model names. So these are, in English, Meta Llama Instruct 8 billion. We've got the 5.3 medium, 128K Instruct. We've got all these different models, and we're sort of passing this on and gaining this access from GitHub itself. It's super easy, and it's not really that intense at all. If I can go to the system prompt, you'll be able to see that, here we've got some a simple system prompt. Hello, I'm an AI assistant. I will try to answer the questions about King's College London, which is my university. And to make this super interesting, we added some RAG applications here where I added, just yesterday, a .text file all about King's College London. We've got its, when the faculties, the different students, but it's just a .text file. And what's really amazing is that the application I can show here is directly querying from the vector database of the King's College folder. So it knows all about the data that I've got in my application. And now let's see if I ask it some complex questions, how it's going to react. So if I just run chainlit run app.py and give it a second. There we go. It's hosting. I can open it up in browser. Great. So here we've got the Chainlit front end, which is great. We've got the assistant, which says, hello, I'm an AI assistant. I will try to answer questions about King's College London. Amazing. What we can do here is we can really specify the LLMs that we want to use. So first of all, we have to specify, we can use 128K medium as the LLM model. And then the router model, again, is the same, 128K. Now here, there's a specific difference. So the router model is used for routing the requests and understanding, getting back and forth from the data that we had in the database prior. And the LLM model is really what's used to generate the response that we see on our screen. So let's click confirm, and now let's ask a question. So when was King's College London founded? You can see it's querying. There we go. So King's College was founded in 1829. It was established under the patronage of King George IV and the Duke of Wellington. Fantastic, but you can see that it's not verbose at all. So let's try and explore a different model and see how else it may react to the prompt that we want to ask it. So let's move on to the meta models and let's see how this performs. So let's say if I ask, what are the different faculties at King's? There we go. So it's a bit more of a verbose answer. King's College has 9 faculties. You can see all of our amazing faculties there. And it talks about, how it has a wide range of disciplines and organized into various departments. Great. Let's just do one more example since we have the time. And maybe let's pick the small instruct model. And there we go. And let's ask it, how many Nobel laureates graduated from King's? Sorry, this is a subtle flex, I think. Oh, it seems like it wasn't able to respond to one of my answers, but that's okay. So yeah, I guess we have some experiences of struggles and failures as well, but I think I gave you a good example of how we can use demos like this to really evaluate our different models.
Great. So if we go back to the slides, so again, great little demos there, and those are available for you to download and utilize. So we have this QR code for the Onyx demo, which takes you to the Hugging Face demo, which was shown, and then this QR code for the Chainlet app. Again, please experiment with these. As Rayhan showed you, just simply change the system prompt. He gave it new text files for that RAG data. Again, I think there was a double quote issue because it had Kings with a hyphen of an issue with the prompt there, so don't worry about that. But again, we want you to play and experiment with these to understand, like, number one, evaluate models. See what the difference is between the output of those models, and then how to best optimize the model. And this really brings us on to the opportunities of small language models, apps, and devices. So at the top, we have our small language family from Microsoft. So we start with our Phi 3 Mini, which is 3.8 billion parameters, all the way up to our Phi 3.5 MOE, so our Master of Experts model, which is a fine-tuned model, which is a lot larger. It's 42 billion parameters, but it's very, very small still. It's still a small language model. Then we have the opportunity of how to get access to these different models. So we can use Hugging Face, we can use the Azure Model Catalog, and we use the GitHub Model Catalog. As Rayhan showed you in those examples, he was using the Azure Inference API, which is just a standard API for accessing models. And all you're simply doing is passing the model name, which is in the catalog, to access that model. So you're not changing any code. All you're doing is just changing the model name. And then again, that application in Chainlet is a great example of showing you how to do that. Again, he used the GitHub Model Catalog, which is completely free. So if you're a student, you get a free GitHub account, you get free GitHub code spaces, and you also get free access to the GitHub Model Catalog. Again, developers, you get free access to the GitHub Model Catalog if you have a GitHub account. You do have to pay for code spaces at the moment. I'm sorry about that, but you get 60 hours for free, which gives you a great opportunity to experiment with this. And then when you want to deploy to this, we want you to be able to deploy to any device. So whether you're using like an NVIDIA Jetson, a Raspberry Pi, an Android phone, an iOS phone, a Windows PC, you'll be able to deploy your model to that device and run it on that local device. And what's really exciting now is the whole Windows Copilot or AI PC roadmap. And this is all the new Windows devices, whether they're from Intel or whether they're from Qualcomm's, the Snapdragons, have Windows AI PC enablement. So they have an NPU chipset on the device. And they also have Phi Silica built into the device as well. So Phi Silica is an OEM version of the Phi model, which allows you to run Copilot and Windows Copilot apps natively on the device, non-internet connected, which is amazing. And what we're doing is we're building out the developer story there to build NPU-driven Windows applications. So have a look at aka.ms/WCR, which is a Windows Copilot runtime. Lots of lovely demos and examples of how to use NPU-driven applications. Again, you will need one of these latest devices to run the code and to experiment with this, but there's some amazing applications on there, like taking a OneNote version, but then being able to highlight the text, summarize the content, speak to the content and have automatic dictation. Again, pretty unlimited, because you can do anything you can do with a large language model or a small language model in a Windows application. So our real goal for developers out there is develop in the cloud, but deploy anywhere. And I think this is a real key opportunity today around where we're going with IoT, or IoT-enabled devices, from smart TVs, infotainment systems in cars, etc. And we're really looking at these 4 key pillars. So it's number 1, being able to provide access to those cutting edge models and APIs. And again, as Rehan showed us, the model catalog has over 1,800 models today from all different providers. And again, even specialized business models. So there's models in there that have been fine-tuned for specific business cases like health, industry, etc. Again, it's about having that complete AI tool chain. We want you to use AI Foundry as that complete tool chain to build, deploy, manage, and then choose that responsibility, evaluation, and continuous deployment of your operation. Again, we want you to build responsible AI solutions. That's so key. But also we want you to have those enterprise grade scale applications where you can have security, boundary controls, responsibility around the applications, services, and features that you offer, and be able to deploy those on the edge, be able to deploy them in embedded devices, or take them to other platforms and other opportunities using the Onyx model. And I'm going to talk a bit more around where we're going with Onyx and the Onyx roadmap. So Onyx is really about bringing that application to any device. And what we utilize is a service called the Onyx Runtime. And the Onyx Runtime is a wrapper around those models, which allows each of the DLLs from different access providers, so from hardware providers, to run your application and access that model. We have a thing called Olive, which is Onyx Live. And Onyx Live is about the optimization and quantization of your large language model or small language model to be operationalized by the Onyx runtime. So be able to access that model and store that model as a locally embedded model. And it's really about the opportunity there of utilizing these tool sets to really build into your developer, into your developer tools, so that you can utilize and undertake this work and do it very, very effectively. So for example, the Olive CLI, so the command line interface for Olive, allows you to fine tune a model within about 20 lines of code. And at the end of it, you will have a fine-tuned model based on your own data that you've given the model, and also a set of DLLs appropriate to each of the different platforms. More importantly, we're in this era, or we're going to be coming into this era, and this is the exciting part for me, is what we call EP, so execution providers. So imagine where we have a local device, like a mobile phone or a smart ring, where we get an answer from the small language model on the device. But if the small language model isn't good enough, or the user doesn't think it's good enough or wants more details, we can then call off to the cloud if we have connectivity to have the execution provider execute a large language model or a different fine-tuned model. So again, this is really a new opportunity where we can start to offload things between local compute, cloud compute, and have different inferencing and different responses back based on that engagement of the user. And this really ties in with the whole era of agentic frameworks or agent-based AI interactions. So let's expect to see a lot more around this area as we go forward into 2025. So if we look at optimization and performance around the Onyx runtime, this is a high-level overview of where we are with the Onyx runtime. So we start off with our AI SDK, so our inference APIs and SDKs, which is now called the AI Foundry SDK, and we can have models hosted in the cloud. So we have models as a service, and you're simply calling that model into your application. So exactly what Rehan showed us. He's calling the endpoint, he's calling the model name, and he's doing the inference. Onyx allows us to take that model and then deploy it and make it specific to each of the different runtimes. So we can have CPU enabled. So if you just want to run it on a CPU machine, it's optimized. If you want to run it on a GPU, if you run it on an NPU, or if you want to run it in the web browsers, we just saw, Onyx Web is amazing at building those custom models. And then on the devices, we've got CPU, GPU, NPU, or we can offload back to the execution provider to a cloud. So we can do CPU inference, doesn't understand, offload to the cloud, use GPU, bring it back to the end user. And we're working across lots of different hardware providers and partners. So Azure is Microsoft, of course. So, that's our execution provider. Qualcomm have QNN. Intel have OpenVINO. And again, you see lots of things around OpenVINO. AMD have Vitalis. Microsoft also has DirectML. And then Microsoft and Intel have the WebNN standards. And again, this is all open source. So have a look at the QR code that will link you to the Onyx Runtime website and Onyx AI websites. And again, you'll be able to see all the different things that we're doing around the frameworks and optimization experience. So again, it's really key that we want to bring these devices to you. So get that compute as close as possible. Less engineering effort. We don't need to create 100 applications. We need to create one, be able to inference the same model, but bring it back to that device. Again, ease the burden from a development perspective. Management of code, management of those resources, quality checking, unit testing is really key. So if you've got lots of different versions, it becomes a huge burden. And again, it's really down to you then as a developer to control the UI and the UX of the application to make sure it fits the user experience based on the device, whether it's a smart ring to a mobile phone to a 40-inch screen. So what we're going to do now is I'm going to step into a demo around utilizing a model. So this is a scenario where we've built a recycling solution. And in this recycling solution, what we're going to do is we're going to basically take an input. So I've got a couple of cameras here, so hopefully it all works. Demo gods, please be with me. But we're going to take an application that's designed to be implemented in a recycling situation. So the idea is somebody walks up to a camera with an item and says, is this recyclable or not? And the camera takes a picture, it will call the model. And we have, in this solution, we actually have two models. We have a local-based model, which sits on your machine. You will need a GPU to do this. And we also have a cloud inference-based model. So it will go off to the GitHub model catalog, choose the model, and bring it back. And we're going to use the Phi 3.5 vision model to do this. So we're showing like we can do what we call multimodal. We can take input from a camera, take an image, then display the results back to the user. And again, we've sort of tailored the results. So I'll show you some of the code of how we've tailored the results down. So it literally says yes, no, or it might provide a little bit more detail, but it's not a huge verbose answer. It's very concise and it's going to give you a visual representation of is it recyclable, is it not recyclable. So if we can switch to my screen. And hopefully you'll be able to see my screen in a second. So let me know when you can see my ad. Perfect. Here we go. So this is my other camera. So hello, I'm just looking at that camera, but I'm on this camera as well. So this is going to get confusing for people, especially for me. So what I have here is a Gradio app. So this is the actual application that we built. So I'm just going to go into VS Code to show you what this solution is. So as you can see, this is called the recycling solution. And what we basically designed this to do is to identify plastics and cardboards and say, is the item recyclable or not? We actually built this using the Gradio framework, and it's using the Phi 3 vision, and it's using PyTorch to do the model inferencing. So what we're doing is we're using the camera to take an image of the prompt, and then we're actually providing some key outputs. So we've created in our UI a set of bounding boxes, which is basically an image for the video input or input to upload a file. We've created a sign that's going to display if it's recyclable or non-recyclable, and we're using two icons for that. And then we've provided a prompt box, which will provide the output of the model to actually say, is this recyclable or not? And as you can see, this is a really small application. It's 44 lines of code in the recycling application. And what we've done here as well is looked at how we can actually host models from a local perspective or host models from a remote perspective. So in the actual solution, you can see in the local model, we are referencing a model local to my local machine. So this is calling a model which I've downloaded from Hugging Face. It's a Phi 3 vision instructor model, and it's literally the snapshot of the version of the model. So this, I've just gone to huggingface.co, downloaded the model, stored on my local machine, on my local drive, and the code is referencing that model. Very, very simple. In the cloud-based model, I've literally done this is exactly the same code, but the code is actually calling the inference API. So you can see it's calling the inference API, and it's calling the Phi3 Vision Instruct model, and it's using my GitHub token to actually authenticate, because again, I just need a GitHub account to authenticate, and that's stored in an environmental variable. And then it's just going off to the inference API. So if I wanted to change this model to be a different vision model, I just simply need to change the actual name of the model. So just change this name of the model. Again, in the localized model, super customizable, exactly. So I can evaluate immediately which was the best response. Which was the fastest? Which one did I want to change? You know, what's the benefit of going to GPT-4o? As you can see in the markdown we've added, you know, you can actually just change this to GPT-4o and compare. Was Phi3 faster? Was Phi3 cheaper? So again, would you want it cloud inference to local inference? So again, really, really scalable. So I've run the application and I've got the Gradio site, which I showed you earlier on. So if I just go back to the Gradio site, and you can see this is the UI. So I've got my video input. I've got my box, which is going to give me the result in an image, and then I've got my output prompt. So what I've got a couple of props here. So I've got a PC box, so it's a cardboard box. So I'm just going to literally hold this up. So the intention is that somebody walks up to the application and says, you know, like, is this recyclable? So they walk up, take a picture, and let's see what happens. So it's took a picture, it's loaded the picture. Well, I've got an error. Let's just refresh this.
Sometimes demo duck, yes, of course.
Yeah, it's been sat there for a while, so let's just check it's not just that. Change the camera back. So you can see this is all live.
Amazing.
There we go. Let's take a picture.
There we go.
That looks better. It's doing something.
Hey, there we go.
So you say no, trash it. Ooh, that was interesting. So let's hold something else up. Let's see what it does. Let's see if it picks it up as a being a bit better in that way around. So let's just do.
There you go. All right.
So you can see that the actual solution is actually doing a bounding box. It's now figured out it's a cardboard box. It might have been the light.
There we go.
So you can see I'm actually in the picture. And I've got a printer in the picture. There's a doorway. There's lots of different items, and it's actually identified that item as the thing to be recycled. So again, I've got other things. I've got a remote control. Let's just see what it does with a remote control. I'm sorry, I have to keep changing the camera. It just defaults back to this camera. So again, I've got remote control. So let's just take a picture of the remote control. So again, I'm just literally holding this up, you know, and again, it's identified it and saying, no, that should be trashed. It's an electrical item. It's not recyclable. Brilliant. So we've built a really small, lightweight application. So it's like 46 lines of code, 96 lines of code in the helper file, which is actually calling the inferencing and the model. But this is a really cool application that can be deployed to a Raspberry Pi device sat at the edge. Really, really cool. So let's go back to the slides. Cool, and both cameras worked, which was amazing. Woohoo! So, you know, what we'd love to do now is we'd love to open up for questions. You know, you've seen what we can do with small language models. We've talked about the difference between smaller language models. We've talked about the GitHub model catalog. We've talked about the inference API. We've talked about Onyx and deployment at the edge. And we've shown you how fast this inference is. You know, it's like seconds to get those responses. So is there any questions, Maria?
Yes, so we do have, excuse me, we had some questions at the beginning of the session. So we're going to give some people a minute or two to type any questions that you have in the chat. But we had questions at the beginning. I'm going to share it now also on the screen.
Cool. So the question is, can we build an AI model from zero to final product with free resources? No, it's the easy answer. You cannot build a language model. Language models cost billions of pounds to produce, okay? Billions. So, you know, people like Microsoft, Meta are building the language models, and open source providers are building language models. But to build a language model from the start, you need vast amounts of data, vast amounts of compute. So there is no way you can do it for free. Just the compute cost alone, no. So you cannot build a model for free. To fine tune a model, you can take an existing model, add the data to that model, fine tune the model, but you will be paying a cost for the fine tuning. So you'll pay a cost for the compute time it takes to run the fine tuning job, and you'll pay a cost for the number of tokens it uses to put the data into the model and get the data back out of the model. If you wanted to do a RAG solution, you also pay for a RAG solution. So our recommendations, if you're new to this, we utilize a thing called vector stores. So it can either be a database or it could be Azure Search. Azure Search is the best way to get started because it will create your vector indexes for you automatically, but you pay a cost for storage, the data that you store, and a cost for the running that service on a basis. So you cannot train a model for free. So apologies.
Okay, and we have one more question.
So though it's correct calling Phi MOE a small language model, it's a small language account for the active parameters, but it's still large in total number of size. So yes, so it's still a small language model because it's part of the Phi family, but MOE is basically what we call a methods of expert. So it's been a finely tuned model which has enhanced the quality of the models, but the model is still quantized and it's still a small language model because it's based on the number of parameters overall. But yeah, so it's still a small language model, but it has a large number of parameters.
We have another comment from the same, it's just a comment, not a question, but regarding the previous question. So sharing it.
Yeah, here. I was just going to say to Oz Covers, I'd be very interested in how much he paid to make an 8 billion parameter model. I bet it wasn't cheap.
And we have a question from Ludo from US Berkeley. What allows SLMs to outperform LLMs? How do we practically achieve a higher quality with so many fewer parameters?
Yeah, so it's really about it's a great question, Ludo. So it's really about going back to like the first set of slides we said about, what is your specification? What's the requirements of what you want to do? So let's take an example of, you want to be a travel agent. Okay, it's a good example. So to be a travel agent, you might need to know about flight bookings. You might need to know about excursions. You might need to know about hotels, specific hotels and for specific providers. You might need to know things like weather. So if you look at a large language model, large language models are literally know the internet. They know everything. So all we're asking for is 5 different sets of parameters. So what we want to do if we're fine-tuning a large language model for a travel provider is basically train it so it only knew those parameters we were looking for. So we want to strip away as much of the data as possible. So if we're starting with 175 billion parameters and we want to get to 8 billion, we've got to get rid of a lot. Whereas if we're starting with 8 billion parameters and reducing that down to 2 billion, we're not consuming as many tokens. So number one is it's far cheaper to fine tune. And number two, the inferencing is going to be so much faster because we're making the model much more optimized. So you'll get far higher quality. And this is when, like at the announcements at Ignite a few weeks ago, there was lots of industry models being launched from the Phi family. So like the Bayer model, I think there was a Novartis model. So, and there was a couple of healthcare models which have been fine-tuned from Phi 3 models because they've started very small, removed all the rubbish that they don't need, and made it very specific to the use case. And this becomes really important when we want to build those agent scenarios. So if we go back to like that travel example with 5 different things we're looking for, we can build agents based on each of those things. So we could build an agent who knows about the TUI catalog. It doesn't know about Expedia catalog. It knows about TUI. We might just build a model for Asia because it's an Asia brochure. We might just build it for a single airline. So their models become super, super small. And again, think about this from like a booking perspective. So an online host or an interactive terminal. We've built these really small agents, which are master of experts in their specific field. So the answer is like bump spot on, 99% accurate. But great question.
That's great. I think if I have something to add on. So Lee, if I'm getting this correctly, if you have a small language model, where sure, it's got less parameters, but it's more focused on the applications of what you're training it to be on, and it's more fine-tuned. It will give higher output, better quality answers than a large language model, which has no idea about your data specifically, although it's quite large and it's got a lot of sort of irrelevant parameters.
Yeah, and again, the chances of like misinformation or hallucination becomes less because it doesn't have that verbose set of information it can think, oh, is it related? Because it comes down to vector, doesn't it? It's the vector of the next probability. Any other questions, Maria?
Yes, we have one more question also
Cool.
from Ludo. Does your SLM recycling solution use fine-tuning or RAG?
Great question. It uses nothing. So that's using the based 5-vision model. So yeah, it's a completely untrained model. So I'm so glad somebody asked that. So that's why I purposely showed you the inferencing API. We're calling the 5-3-vision base model, and we've downloaded the base model, just like the specific version date of the model availability from Hugging Face. We have done no fine tuning on that. And look at how it identified the cardboard box. It didn't think about me. It didn't think about the door or the printer. It just knew the box because we're using like bounding controls within PyTorch. So this is the power of the small language model. Again, if I wanted to fine tune that to identify an Xbox controller, I'd just say, this is a black Xbox controller. That's a white Xbox controller. When I hold it up to the camera, it goes, it's an Xbox controller. It's this model. That's the power of small language models. And again, this is where small language models become so key in industrial applications like robotics, or I keep going back to cars. All our cars are becoming more and more intelligent. They need to identify road signs, pedestrians, dogs, street lines. This is where small language models are going to be so key.
And I think we have time for one last question, also from Ludo, another great question. I'm going to share it now. What is the overlap between SLMs and AI agents?
Yeah, so again, just going back to what I was saying there, with an AI agent, you're going to have a different agent for your agentic workflow. I don't think anybody going into 2025 is going to be building a single agent solution. Everything is now called agentic frameworks, where you're calling a different set of agents to become that master of expert in terms of the response. So if you think about, where you want agents on local devices, it's like going back to, an agritech solution or a drone solution where, you might be flying over a field with a drone, but you want an agent that will identify crop patterns or pests, etc. You would want that as a small language models. And again, you want that to be as optimized as possible to make sure the footprint is as small as possible to that solution. You might say, we build a single fine-tuned model. Great. But what other agents do you need in that process? Are you going to be calling off like to M365 Copilot agents or, APIs that are driven from pesticide companies? I don't know. So, but this is where we're moving to now. So the overlap between small language models and AI agents, I think, is going to become far, far closer in building the most optimized agent solution. But they're going to be fine-tuned models for each agent.
And we're just out of time, and we don't have any additional questions. So yes, any sure. Last
Yeah, so my last thing is, we do have this Azure AI Discord community. So if you search for Microsoft AI Discord community, or you scan this QR code or go to that hyperlink, if you want to carry on our discussions, I'm in that Discord group. We've got all my team in the Discord group. We really want to help people get started on this AI journey. As I said, no one is an expert. Things are coming out every single day. We want to give you the maximum level of information to get started. We want to inspire more students to become Rayhans of the future. We want you to become student ambassadors, work with us on this amazing content, be able to share and deliver your experiences and build amazing AI solutions.
Great. Well, yeah, just to add on to that, well, thank you so much, Lee, for setting up this session. Thank you to everyone who managed to join in and learn a little bit more about small language models. As a student ambassador, it's really my role to bridge the gap between what we're taught in university and what's actually going on in the real world. So hopefully you guys gain a little bit of insight into that.
Okay, so that's it. I think also from my end, we received great feedback in the chat. Everyone's super happy and thank you for the session. So thanks again. Everyone who joined, the session was recorded, so it is available on the Reactor YouTube channel. And we hope to see you at the next Reactor event. Thank you and bye-bye.
Bye, everyone.